Hello, everyone, and welcome to today's SANS webcast, ICS Active Defense Primer. My name is Debbie Gruy with the SANS Institute, and I'll be moderating today's webcast. Our featured speaker is Kai Thomsen, DFIR lead at AUDI. If during the webcast you have any questions for Kai, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Kai.
Thank you, Debbie. Hi, everyone. Actually, good evening from Germany. It's 8 p.m. right here. We'll be having a webcast with a little bit of fun in the background. There's a couple of thunderstorms coming through. So if you hear some rumbling, it's not me or my stomach. It's outside. Just before I get started with my slides, just a real quick reminder here that we have ICS Europe coming up in just 2 weeks. And lots of what I'll be talking about really fast over the next hour. We'll be dealing with in-depth in this. There's still time to sign up for the conference, or if you choose one of the classes, I'll be teaching ICS 515 there. We'd be happy to see some of you. With that, let's get started. And one thing before I get started with the slide deck, this is usually a 2-part webcast, so it's even shortened. It's like 40 slides, 35 slides. I won't be going over all of them in the next hour, but I wanted the whole deck for you to be able to download, so I didn't throw anything out. But I'll be jumping over a couple of the slides real quick, or just not showing them at all. It's mostly for you to read through afterwards. So yeah, this is me. We've been there. So let's quickly explain what all this active defense thing is about, and especially if you're dialing in from Germany tonight, although we do have a holiday on top of it's 8 p.m. We just recently, like just the last couple of weeks, had this discussion in Germany about active defense and hackback, and our Minister of Homeland Security, who actually lives like 6 miles away from where I live, so he comes from the same part. Maybe I should show him that slide deck someday. Just kidding. The whole discussion that has taken place in the United States 5 years ago is now taking place in Germany. So should we hack back? Should we steal back the data? All that. This is not what active defense is about. Active defense is about actively looking for adversaries in your environments and then dealing with them. And to begin with, know who's after you. And here's on this slide, you see a couple of the examples that most of us had to deal with over the past couple of years. WannaCry, NotPetya is probably something most of you are familiar with. If you work in any kind of consumer goods manufacturing, or like me in the automotive industry or any type of industry, you probably had some fun 2 weeks trying to patch the latest Microsoft Windows remote desktop vulnerability, that CVE 2019-0708, where people are saying, and especially Microsoft and German BSI, and I think NIST or DHS CERT as well, this has the same potential as the vulnerability in Windows that was used by WannaCry, Eternal Blue, back in the day. So there's a lot of untargeted stuff going on that we have to deal with in a very structured way, put it like this, that makes the whole concept of active defense and what that exactly means, we'll get to in a bit, much more effective than how we might have dealt with these things previously. Also, if you look at targeted attacks, I mean, probably some of you have read about the cyber attacks against Ukraine Power Grid 2015 and 2016, or you might have read something on Trisis, which was the attack in Saudi Arabia in 2017 against a refinery taking out their safety instrumented system. So actually the system that's supposed to cut in if the manufacturing process threatens to go out of control. So attacking these is kind of really crossing the line. But what's probably closer to most of us is what happened just earlier this year. Norsk Hydro, Arizona Beverages, ransomware, but not ransomware getting sent out with a phishing email and then people clicking on it and files getting ransomed left and right, but the stuff getting placed inside the environments quite a while prior to the actual attack, and by means of what we usually attribute to APT, so advanced persistent threats. And why is that? It's because ransomware is basically too effective. If you send it out via phishing email, then everybody that clicks it, everybody that opens the attachment, everybody that runs the malware unwittingly gets their files encrypted, but most people just don't know how to pay the ransom. I mean, who knows how to pay with Bitcoin, right? No one. And if it comes to big companies, there's so many legislation around how we're not supposed to pay ransoms because we might be financing organized crime or even terrorism. So the whole thing, long story short, doesn't really work. So although ransomware is highly effective, criminal gangs weren't really making a lot of money with it because it was too effective, and the payment methods basically just suck, in plain language. So what teams started doing over the past one and a half years was using more targeted methods to ransom environments, like pre-selecting certain targets. And once the dust settles over the city of Baltimore and we see some more stable incident response reports coming out of that, we might figure out that might have been another of these targeted ransomware attacks. We just don't know yet, but this is probably one of the examples. But Norsk Hydro, Arizona Beverages are some good examples where exactly that happens. There's a couple of others. If you're in southern Germany or this part of Europe, you probably heard about Kraus Maffei, just ended last year, same thing. So this is an ongoing thing. So what do you do when human teams go after you? You need a human team to go after them. I mean, that's basically how it works. Or I mean, it's past 8, so actually I should be sitting watching Netflix. So if you watch one of these CSI crime shows or whatever, it would be like, what's the best method to counter a hacker? Another hacker, like the whole thing with the snipers. Like, what's the best counterattack to a sniper? Your own sniper that finds them. And actually, that's, I mean, yeah, cheesy movie examples, but actually there's something to it. You need to think things through because it's not malware that's after you, and malware doesn't grow in trees. It's human teams that are after you. So you need a human team as well that knows how to deal with that. So a quick example here is sliding scale of cybersecurity. That's usually what we show management. My friend Robley wrote this white paper, co-authored it with Mike Asante. You can download it from the SANS reading room, and yes, shameless plug for SANS classes, they're in there as well. But the most important takeaway here is, of course, if you've done any type of IT security in the past, you know that most of the stuff that we do works a lot more effectively, or doesn't even bother us if we're good at architecting environments that are secure to begin with, or that are at least defendable. And we know how that usually plays out in the real world, but we still have to remind ourselves and everybody else that's working in IT and for ICS and OT environments that we need some kind of defensible architecture. And not you layer passive defenses like your typical AV, firewalls, intrusion detection, modern endpoint detection and response tools, what have you. And all those tools are supposed to be there to automate away all of the threats that can be automated away. And then on top of that, you layer active defense. And actually, passive defense tools become a lot more effective once there's an active defense team that knows how to look for threats and how to translate a threat behavior into how do I detect this and how do I deal with this so it goes away or it becomes ineffective at least. So usually you should see those two here in tandem. So active defense and passive defense are actually what becomes a good coupling there. Once you go past that stage and become more settled and a more mature organization, it goes intelligence, and that's not consuming intelligence. You also already do that during active defense, but creating intelligence. So learning from your threats, collecting that data, exploiting it. That means leveraging what you learn about the threats to become better at what you're doing in IT security and also improving architecture and so on and so on. So this is the whole cycle which we see here. This is the active cyber defense cycle, and yes, of course we put a cyber in because yeah, cyber and it's AC/DC, right? And everybody has to have an AC/DC acronym nowadays. So basically what you do in active defense is you consume threat intelligence if you're not mature enough to create your own, and most of us aren't, frankly, including my own organization, but we consume a lot of threat intelligence. Of course, you do asset identification and network security monitoring. I'll get into that in a bit and why this is to me the most important thing. If you start looking for stuff, then I guarantee you'll find something. So you should have at least some preparation and planning around incident response and some people that know how to run incident response. And then just to sort that out so incident responders don't have to do like 10 things at the same time. What we do, especially in the ICS 515 class, but what also makes sense conceptually, even in enterprise environments, is malware analysis and learning from malware gets sorted out into a different team, and we call that threat environment manipulation. And I'll show you later why that totally makes sense. And I'll give you an example that's not in the slides, but you just have to listen to me there for your common crimeware and how we deal with that at Audi. And it makes a lot more sense what I'm talking about here. Just real quick, because methods are important, and especially to me, and especially how I'm building my teams at Audi. So I'm working in a integrated OT IT defense team. So we as CERT Audi, cyber defense team for Audi, are responsible for the enterprise and the shop floor, so the ICS environment, but also the infrastructure that connects to the vehicles. So not the vehicles themselves, that's another team, but we closely collaborate with them. But everything that gives you data points inside the vehicle or where we collect data from the vehicles is my team's responsibility. So methods are really important, and knowing what is what. Welcome to the cyber kill chain, and this is the ICS version. And why is this so important? Just real quick again, usually your adversaries are not directly inside your ICS environment to begin with. I mean, that's why people use computers to conduct espionage or sabotage, because they don't have to be on location. So the way they get into your environment will start at left-hand side stage one. They'll first intrude in your enterprise environment and then try to pivot into your ICS environment. And first things first, they have to learn about your ICS environment to begin with. ICS environments are very, very specific to a certain site. If you're, again, in consumer goods manufacturing, or if you're working in the oil and gas industry, or if you're working in automotive, you know that, of course, there are certain standards that we're all base our environments on. If you're buying an environment from certain vendors, then certain technologies are all the same, and people try to build assembly lines kind of copy and paste, and it never really totally works. So it all gets tweaked and customized, and some environments are very, very customized. Some equipment is very specific to certain companies and assembly lines. So again, long story short, these environments are very, very customized and tailored, and there's probably not that many environments that look exactly like yours out there in the world. So the adversary has to learn about your environment first. How do they do that? They get into your enterprise environment and try to steal all the information about your ICS environments they can get their hands on. So maps, plans, schedules, equipment lists, so inventory, project files with the programming for your PLCs and what have you, all of that stuff, but also learning about how the organization works, what the connections are, how maintenance works, what type of connections you have between the enterprise and the OT environment, and on and on and on. And once you have that type of information, then you start to prepare your actual attack into the ICS environment. But for you to be able to do that, again, you need all this information. So let's look at this the other way. For us as defenders, we have twice the opportunities to spot those people going into our environments, because they have to be in the enterprise environment first before they can pivot into the OT environment. So actually, that's a good thing for us as defenders, because we have lots of opportunity to detect them. And that's something that you always need to leverage on. But it's the same if you're defending enterprise environments. You're a successful defender not if you prevent every intrusion. You're highly successful if you spot most of the intrusions and then know how to deal with them quickly. That's how you should define winning in your environment. It's not stopping everything and preventing everything. That never works. It doesn't work in the real world. I mean, there's still burglary, there's still break-ins, there's people breaking the law. So same thing in the IT world, right? Just let's compare this realistically and set realistic goals. So again, it's not about stopping every intrusion. It's being able to spot, hopefully, most of the intrusions and then knowing how to deal with them. So let's quickly start with threat intelligence, because this is usually where most of the misconceptions are. So, and as we're spinning up our team, and Audi is part of Volkswagen Group, so we all have the same program right now where we have to spin up incident response or active defense teams. So Volkswagen Group consists of 12 different car and truck brands. So you can imagine a lot of people and a lot of different wordings and different definitions of terms and what we do. So it's not easy to come to terms with. And if you start with the usual standards like NIST 802 or ISO 27001 and 27034, there's always something to be left with. So when we thought about what's threat and what's actually our responsibility as a cyber defense team, we looked into the definition that was created by Idaho National Labs. So if I closely follow ISO 27001, then even a failing hard drive could be interpreted as a security problem. I certainly don't want to have that workload for my team. So the definition of threat that we work with is an adversary that has the capability, hostile intent, and opportunity to harm to our organization. So it's someone, an individual, or usually a group of people that are after you. So what's the most effective way to figure out how people operate that are after you, or how to spot them? Figure out their mode of operation. It's not looking for atomic indicators like IP addresses, malware hashes, and all of that stuff. You know how easy it is to change that. But if you think about human behavior and how difficult it is to change that, that's what we usually want to deal with, right? So we want to look into how are people behaving, like tactics, techniques, and procedures. And also we want to know about what does our organization, or how do our organizations look like to potential adversaries. So that's what we call threat landscape. So what information is out there about my organization that could be leveraged by an adversary? So I can't probably can't stop that information from being out there, but what I can do is understand what's out there. So that gives me an expectation of from where the adversary might try to get into my environment, or how they might start messing with people when it comes to social engineering and stuff like that. If you think about CEO fraud and all this type of stuff, then information out there about how your organization is set up, who's who in your organization, all of that becomes really important. But same thing when it comes to espionage and sending people spear phishing emails. If they know what the departments in your organization are that are most likely to open emails all day and click on PDF files or Word documents or what have you, then that's probably who they going to target. Things like that. So aim, whenever you consume threat intelligence, whenever you try to learn something about the adversary, aim for tactics, techniques, and procedures, not so much for indicators of compromise, because they don't work as effectively as some companies that sell that type of stuff, threat feeds, might tell you. Let's put it like that. Also, just recently when I gave a talk at the SANS CISO meeting in Munich, people asked, what's the first step? How do we get started? Well, how I got started with that for my team as a training exercise, especially when you try to onboard and train people on how to do intelligence analysis, was just let's have a look at your typical targeted adversaries from Southeast Asia, let's put it like that, and what their 5-year plan is. And if anything that we do as a company is in their 5-year plan, then that might be interesting, because that might put us on their target list. So in the case of Audi, when you look at China, Vietnam, countries that have 5-year plans, electric vehicles and modern forms of transportation are in their 5-year plans. So we probably should be tracking what their espionage teams are doing, cyber espionage teams, and how we might be able to spot them in our environments. This is how you get started, having a strategic understanding about who might be interested in your R&D or how you do things as an organization, and from then that build out horizontally to learn about potential threats to your organization. Some sources, as always, we tell you at SANS to start with open source and then go down the money road. So first of all, you know exactly what you can expect from certain types of information before you start spending money over and over and over. So especially if you're in critical infrastructure, please make sure that you know who your industry peers are and also who your government certs and agencies are that you should have close contact with. So if you're in Europe or in Germany, your national certs, or in the United States, DHS cert, and especially if you're critical infrastructure, and those of you in Germany, yes, in Germany we decided that food is also critical infrastructure, thankfully. Rest of the EU didn't decide like that, so water is important, but not food. Can't really follow that train of thought. But if you're in these types of industries, then you are probably under the National Information Security legislation in Europe, NIS, infrastructure security. So talk to your government agencies, talk to special interest groups, look at open source intelligence, and then there's a couple of companies that can provide you with intelligence specifically for ICS. Currently, there are only 2, and these are Dragos and FireEye. Also, once you have a certain maturity and once you are really good at learning from your own incidents, you will be moving over to internal threat intelligence and how to learn from what you've seen. The big advantage to that is it's directly relevant to your organization because you've seen these adversaries in your environments. Disadvantage is you will need a dedicated team. That cannot be done inside your incident response team. It's just too much of a workload, and also, you should always have a second set of eyes looking over the reports that are created after incident response. It's just because we tend to make many mistakes when we write reports. Now, I'm speaking from experience here. So takeaways, use threat intelligence to focus your defense efforts, so to know what to look for, because we can't look for everything at the same time, and understand your threat landscape. So what is out there about your organization? So real quick, network security monitoring. So the second element of active defense. And this is, to me, given the current maturity that we have in overall in the industries that I'm aware of, this is where we all should be. This is what we should be doing 100%. Actually, we should be doing incident response because, again, speaking about Europe, the General Data Protection Regulation, GDPR, and the NIS, the National Infrastructure Security legislation, demand that we have incident response plans. And usually the laws don't demand that we train those plans and have teams, but a plan that's just on paper is nothing. So incident response is demanded by law in Europe. Who does incident response? Internally, mostly no one. We're not even there yet with network security monitoring. But why is this so important? Because you need to know your environment. Everybody that does defense in the physical world knows that they should have the upper hand in their home turf. And that's how everybody trains, right? Everybody that has responder or emergency in their job title train in their home environment all the time, every week. For some strange reason, we don't do that in IT, or we still don't do it that much. And we keep complaining about this is also hard and the attacker has the upper hand. Actually, that's not the case if we don't throw away the natural advantage that we have as a defender. So if we have mapped out our environment, if we have some baselines, and especially in OT environments, it's actually not that hard to baseline because these protocols and these environments are rather static. I know it's difficult in enterprise environments, but it's not that difficult. It's just a lot of work, but not rocket science in OT environments. But what that helps you on top of becoming highly effective at detecting threats in your environments is also it makes you a better IT environment or OT environment to begin with, because you see all the shoddy stuff, so to speak, in your environment, like all the misconfigurations, all the stuff that broke weeks ago and nobody has really realized yet. You solve the inventory problem in the OT environment, and on and on and on. So if you do your homework here, if your active defense team sets up network security monitoring correctly and starts working with the asset owners in the different parts of your environment, then at the end of the day, you have a much more effective infrastructure and much more effective teams that know how to deal with problems in the infrastructure. So crazy thing here, if you do this correctly, actually IT security will help save the organization some money when it comes to IT operations. How crazy is that security might actually save you some money? This is actually what we're doing at Audi currently, working with our shop floor teams, mostly the baseline, the environment, and we have a huge environment. Just in Ingolstadt at our main plant, we have 4,500 robots. So you can imagine that this is a big environment. So this is not easily done in a couple of months. It'll probably take a couple of years, and then we start over, because when they're bringing out a new car, so like next year, the latest and greatest fully electric vehicle that's coming out early next year, they're usually building up a new plant for that, a new assembly line. So another couple of thousand robots and stuff. But on the upper hand, these environments tend to stay for a long time in most of manufacturing. So we know we have to deal with this environment probably for 10 years or so. So this is real quick, and just skip over this and go on. But if you want to learn all about what the method is for identifying ICS assets and then learn from that, this is a process that can help you. Actually, this is one process I've printed out and stuck to the wall of our lab, so everybody knows how to do this. Some methods how to do asset identification in ICS environments. What you should all be doing is traffic analysis with some physical inspection put in. A, because traffic analysis is passive and doesn't harm your environment in any way. And B, physical inspection is just like the cherry on top. First, it's fun to be in the environment and talk to people and getting to know people and earning their respect and learning how to move physically, and also on the IT side operate in these environments, it's really important to talk a lot to those people. So I'm all for physical inspection, even if it's just visiting people there. Just real quick, focusing on active scanning. Don't do it in standard production environments because you will bring down the environment. I've just done that 2 weeks ago because I was looking for that new RDP vulnerability in our shop floor environment. And 2 or 3 weeks ago, scanners were specifically that vulnerability basically non-existent. So even with limiting and talking to people prior and doing some safety checks in a lab, I managed to bring down certain important parts of our assembly lines. So certain amount of cars weren't being built. So I'm speaking from experience here. Don't do as I do, do as I tell you. Do not do active scanning in live ICS environments. Only in labs, and even if you really have to do this, looking for certain types of vulnerabilities that can't be found otherwise, you've been warned. You will bring down something. I'm speaking from experience here again. So quick, the process, how NSM works. Actually, this is nicked from a book about NSM and Security Onion, and I just forgot the title. I just have the German book here. So if you want to know that title, just drop me a note and I'll get it for you. But it's basically always collect data about your environment, learn how to detect threats, and you learn that from looking at threat intelligence and then formulating that into detection rules, depending on what you're looking at, host data or network data, and analyzing that, whether it's a true threat or something else. So what can it be? Basically, only 1 out of 3. It could be a true threat, so that would need to store incident response then, or it could be a threat, but not something that goes over your incident response threshold, but we'll just group this as one. It's a true threat. B, it can be a false positive. So you didn't baseline your environment correctly, or you didn't write a detection rule correctly, so you deal with the false positive and make it go away. Or C, it could be somebody violating the rules. So somebody doing a configuration change outside a maintenance window, or some admin using a remote admin tool that is also on the list of known adversary tools that they use. So one of these 3 things. But once you know what your environment should look like, once you have certain expectations, and once you have figured out how to effectively do detection in your environment, it's actually real quick and highly effective to figure out if something is a true threat or just something more benign that can be dealt with in any other in another way. And again, what we do in a cyber defense team at AUDI is we deal with true threats. We don't deal with policy violations. And of course, we fix detection when it comes to false positives, but everything that's policy violation just goes off to our governance team or maybe just the admin teams. So we just let them know that maybe they should do something in another way that is more compliant. Yeah, collect what data to collect. Mostly in ICS environments, we are focused on collecting network data because we're not allowed to install anything on host systems. That being said, if you have the possibility to collect host data, highly recommend you do that. Detection, just real quick here, there are a couple of threat detection approaches. I already mentioned you should probably try to figure out how teams are acting and not for look for atomic indicators because these change really quickly and you will run into a lot of false positives. So here's a quick example of what I mean by this. So if you're securing an enterprise environment, if your area of operations is currently an enterprise environment, if you certainly have to deal with spam and lots of it. Most infamous malware that gets sent out via spam nowadays is Emotet. You all know it probably, and you have to deal with it, and you hate it, and it's your daily job. So we're really bad at stopping spam for a number of reasons, and most of them are not technical, but more organizational and how regulation works at my organization. But when you try to wrap your head around it, I mean, spam mails change a number of times during a day, usually, if there is a huge new Emotet campaign. So expending a lot of work on catching every single spam email probably doesn't make a lot of sense when it comes to resource usage. But if you understand the behavior of Emotet, and it usually comes in a Word document that has some Visual Basic for applications, so a VBA macro in it that opens a CMD, a command shell on Windows, that starts PowerShell, there you have a behavior. So whenever you see something that is a Word document that opens CMD.exe, that opens PowerShell, so you have this process tree of Word, CMD.exe, PowerShell.exe, you know something malicious is going on. So if you have a modern AV solution or host intrusion prevention or EDR tool, and you can use that to stop certain process chains from working, just whack everything on the head that is Word CMD.exe PowerShell, or just Word CMD.exe, and you're done. Emotet can't be installed in your environment. So instead of trying to whack every single piece of spam email on the head, you're just dealing with the threat behavior that is a certain way of trying to install malware in your environment, and then you're done. This is what I mean by the effectiveness of dealing with TTPs, because changing TTPs will take teams time and money, so they won't do it if they're still successful with their old approach. Analyze mentioned that already. So do I have to do incident response or not? So I guarantee you that in your environment, you will come up with your own threshold for that, and management has a lot of say in that. Actually, that's their main job, to tell you when incident response should be spun up or not. Usually incident response will cost a lot of money because people have to drop everything else and now work in an incident response team. Most of us also have to call whoever externally helps us with incident response, so security companies. They cost a lot of money, and rightfully so, because it's a difficult and stressful job, but it means money and people go somewhere else where it's supposed to be. So there has to be, again, a threshold for decision when we have to spin up full incident response or not. And that totally depends on your risk settings in your organization. So I can tell you have to do that, but I can't tell you exactly how you do that, because that totally depends on your organization. So takeaways here: you need to know your environment to effectively defend it. Select the right detection and analysis approach, and that also might depend on your capabilities in your organization detection-wise. Incident response. The purpose of incident response, and here saying not only in ICS, not just that as it's written, is always maintain a safe and reliable operations, acquire meaningful forensic data, perform timely analysis, and then contain and eradicate threats. So in ICS environments, and most of us with some background in operation technology and manufacturing know that the usual IT approach used to be machines infected, take that off the network and clean it up. That just doesn't work in shop floor ICS manufacturing environments, because we don't know what might go wrong if we just start more or less randomly taking down computer systems. So always maintain a safe and reliable environment. That is always first. But I extend this for my team as well to the enterprise environment. And that is because for most of us, a running enterprise IT environment means organization still makes money. If I take down like SAP or your ordering system or your internet connections, so all of the cloud services that your organizations are using are no longer working, then I'm probably already losing a lot of money from my organization. So from my point of view, and how my team sees this, is we always have to maintain safe and reliable operations, regardless of whether it's ICS or not. And the decision to take down systems, even if it's for us to take forensic data acquisition in those systems or to clean them out, is always a business decision, always. The main goal that we have in incident response is to come up with plans of action for our leadership on what to do next, right? That's our job. acquire meaningful forensic data, scope the threat, understand what's going on in the environment, and then come up with a plan for decision makers to decide upon what to do next and how to deal with that threat. Steps for incident response in ICS environment: preparation, like everywhere else. Always prepare and train a lot. Everybody that has responder in their job title should train a lot. You don't want to be that guy that needs CPR and the emergency responder that helps you. The last time they did it was 5 years ago when they learned how to do it, right? We know that everybody with responder in their title trains a lot. And again, for some funny reason, we think in IT that's not necessary. It totally is. Integrate detection and identification. That's what we do also in ICS, but also, of course, in enterprise environments. We acquire evidence and then do timely analysis. And by timely, I mean quick, right? This is not the full disk forensics from days gone by. This is using fast and well-tested techniques to quickly determine what's going on. And then again, come up with a plan and with some decisions on how to deal with that threat. And again, think back to my Ammotet example, understand, for example, how malware gets installed in the environment and come up with a way that messes with this installation method. Threat stopped, effectively dealt with, now we can start cleaning up. And again, preparation is key for incident response. When a crisis starts, and usually incident response when it's larger is 90% crisis management. You don't have the time or the calmness or the resources to figure out how to do certain things. You have to prepare for that in advance. And you see that when you look at reports, when you look at things going wrong or things going well during incidents, it usually comes down to training and planning, and especially with most IT and OT operations teams, how good their plan Bs are for resiliency. If you look at the Norsk Hydro case, for example, that I mentioned before, and back in the day, I used to work in the steel industry, I had a hand in designing some of the Norsk Hydro facilities when it comes to steel mills, way back when, 10 years ago. But I know that they have some very good plan B type of planning and setups and training, and that's actually what helped them during the ransomware incident as well, because they were so good at operating their plants, at least on a limited basis, even if when their IT systems were down, that's what really helped them in that time of crisis. So again, the takeaway here is to train for this, to have plan B, how to operate in environments that are at least limited when it comes to IT due to a security incident, but also for your incident responders to very well know what they're doing. So hopefully incident response is not the first incident they have to do in your environment. So train a lot. Preparation is absolutely key. Think back to the 4 teams that we have. So when we're doing this as incident responders, and usually that's my day job, I'm an incident responder, I'm working closely with network security monitoring and threat intelligence teams. So threat intelligence is basically my own personal Wikipedia, so they can tell me anything and everything, hopefully, about the threats that I'm facing. And network security monitoring is the eye in the sky. So they see everything throughout my organization. I'm usually operating somewhere in the field, so I'm deployed to a certain site where an incident is. Again, this is mostly crisis management, so you have to be on site. You don't do this remotely from your cozy office, although I love my office, and we have a great coffee machine, but you go on site. You deploy to wherever the incident is happening because you manage the incident. That's the most important thing. So I need the monitoring team to give me situational awareness outside my current site where I am. That's the most important thing. But also feeding what I'm seeing back to network security monitoring and threat intelligence guys, and even if it's just one person each, if I give them back that information, They can start searching for what threat I might be dealing with, so I know how to look left and right for the other stuff that the adversary might have left in my environment. But also NSM folks can start setting up new detection rules based on my findings during the incident response on site, and so extend visibility throughout the environment. That's why this teamwork approach is so important. Evidence acquisition. Most of us that do this in enterprise environments are usually nowadays used to endpoint detection and response tools. So we know how to use our FireEye HX or Cylance or Tanium or whatever to quickly collect data from systems. Not so in OT, because we're usually not allowed to install stuff on OT systems, especially not if they haven't been cleared by the OEM or the system, the component manufacturer. We're stuck with older tools. So here's a list of what you have to acquire. If you look at that, yeah, that's the typical SANS list that you get on any of our forensics posters. Always start with memory, because memory contains the most volatile information as well. So routing tables, ARP caches, and all that stuff, system processes, always memory, and come up with a solution that also works offline. If you have to do this on a shop floor, you'll have to do this with a USB thumb drive. So all the software for collecting should be on your thumb drive. If you happen to ever visit my ICS 515 class, you'll get an example of how we do that in my organization as one of the goodies that I'll give out in class. Or just send me an email and ask me nicely. Acquisition tools, here's a couple of the tools that we work with, and yes, they look like the same that people work with in enterprise environments. There's not much of a difference. Again, the exception is you should not install software on any OT system if it's not been cleared by OT folks. So the list of programs that you can see here is stuff that doesn't have to be installed. It can be run immediately from an external drive, so it doesn't interfere with the software installation on any type of OT system. All of this I've successfully used in my OT environment, so I know it works and I know it doesn't break the environment. Timely analysis. Again, we have to do this quickly because we don't have all the time that we want, always. And again, what we need to do here in this step in incident response is to come up with a good plan of action for leadership on what to do next. So focus on memory forensics, focus on some quick approaches. Actually, you can teach people in 30 minutes on how to spot unknown malware in memory forensics. Yes, it's that powerful. That's all I can say here in 2 minutes. But again, focus on that, the quick stuff that buys you a lot and gives you a lot of information on what to look for in all the other systems that might be affected. When you do incident response, make sure that the incident response team is not the angle, the leverage that gets the threat back into your environment. Also, don't infect your lab systems. So cyber defensible position is a really important term. Takeaway here again is, especially during a large incident and especially during a crisis, and it might be really targeted, it might be really bad, make sure that you know what you're doing, that you have tightened your security, physical and IT security around your cyber defense team and around your incident response team. Make sure everybody knows what they're doing, and always only work with malware inside VMs and not connected to the internet. Don't be that team that manages to get your environment reinfected through their systems. And the rest, just read through these slides, please. Going on. So takeaway here, plan, prepare, and prepare some more. That's how incident response becomes manageable. It's still not a very fun experience. I mean, it's fun if we talk over it months later over beers when we meet peer incident responders from other organizations, but incident response is always stressful and not that much fun, but it becomes a lot less stressful when you prepare and plan and train enough, and there is never enough. And again, focus on timely acquisition and analysis and come up with, again, plans of actions for your leadership on what to do next. Threat environment manipulation, last but not least. So this is basically figuring out how the malware works or how the threat operates in your environment. So if they don't use malware, for example, use RDP connections to get into your environments, that tells you that maybe you want to shut them down, at least for a certain amount of time, to kick out the adversary. Or again, back to my Emotet example, understanding how malware gets installed and coming up with a plan of action on how to stop the installation phase is very effective in dealing with an adversary's capabilities. So this is what threat and environment manipulation does. It tries to understand the threat as good as a team can, also with the understanding about the environment and what might be leveraged in your environment by a threat. You might either want to change something in your environment if possible, or make a change to the threat. Think back to WannaCry version 1 when they had a kill switch inside that malware, and if it could reach a certain DNS domain name, then it would stop spreading. Something like that. More often than not, something can be leveraged that renders malware ineffective. So this is what you have to look for. This is what you have to learn to deal with. So in most of the teams that I see in the industry, this is probably what's being done by an outside team. So reverse engineering is usually not what we do internally, but you have to have someone on their side with good knowledge of the internal environment. So again, this is why it's so important to do the network security monitoring and asset identification part correctly. So then once you understand your environment, you know how to change it to make a threat ineffective. Just real quick malware analysis. What we usually deal with is fully automated analysis or static analysis. So this can be done quickly, even without having years of experience in reverse engineering. There are a couple of good and inexpensive cloud-based solutions out there, and there's always open source as well, like Cuckoo Sandbox, that can help you with fully automated analysis. Just know what the limitations are of all of these, and when you have to revert to the next step and the next and the next. But this is how you do it, and always start with the easy stuff first, so fully automated analysis or some static properties. These are a couple of the tools. So again, just quickly skip over these because we're almost up with time. All of these tools here I use myself, except some of the commercial stuff, but we use, for example, at AUDI hybrid analysis. So nowadays it's called Falcon Sandbox. We're very happy with it, but we also know its limitations. But please, guys, just look this up later when you download the slide deck and just read through it. There's a lot of tools that you can use easily that help you a lot with understanding what's what in your environment and understanding the threat, and then coming up with, again, how to mess with the threat so it becomes ineffective in your environment. Just some quick final words about environment manipulation. There's logical and physical manipulation. So physical might be pulling some cables. Don't do that, again, in an OT environment if you don't know exactly what you're doing. So usually you're dealing with logical manipulation. That might be as easy as having some firewall rules for segmentation of your environment, setting up during preparation, but deactivate it. So think something like WannaCry. And the next worm now happening maybe in the next couple of weeks with the RDP vulnerability. So if you need RDP in your environment, usually you still might want to have, if you have segmentation, if you have a couple of firewalls in your environment, you want to set up some of the firewalls in a way that if something like that happens, you can quickly activate a firewall rule because you set this up in advance and you know your environment. You know what the side effects will be, but this will still buy you some time. So if you can do these logical changes without bringing down your whole environment, it doesn't matter to management whether it's you or the adversary, but if you can do this, it will buy you some time to clean out an infection. So again, think about these. DNS sinkholing also highly effective to disrupt command and control communications. Has to be set up prior, but it's a logical manipulation that can buy you a lot of leverage when you're dealing with threat. Again, takeaways, stay timely. So do this in the quickest way possible. And again, sharing is caring. Threat intelligence is really important when it comes to threat environment manipulation. You don't have to reverse engineer all the malware by yourself because somebody out there might have already done it. So again, reading up about what's going on, how to deal with the mostly known threats that are out there will help you a lot when you face that internally. And with that, I'm almost done. Here's some resources. I think we have 5 minutes left. I'll hand it back to Debbie. Thank you for staying with me with that tour de force of slides. Are there any questions?
Thank you, Kai. That was a great presentation, and we do have a couple of questions here for the Q&A session. And a reminder, if anyone does have a question for Kai, please enter it into the questions window now. Our first question, what are some mitigation actions that might be recommended to reduce risks for that equipment that cannot be patched against a vulnerability?
Very good question and very current. So one, usually when an important patch gets put out, a good CVE, so common vulnerability entry, should also contain some mitigations. Like an example is the current RDP vulnerability. So plan B for that vulnerability is you can change the configuration of remote desktop to use network level authentication. So that's a very specific example. But again, usually when a patch gets issued and you get the information about the patch, you should also get some information about mitigation, so read these up. And then one step removed, having a segmented environment, having firewalls that you can use to at least build a virtual wall around those systems you cannot patch can be highly effective to buy you some time to come up with a better remediation plan.
Okay, great, thank you. Another question came in. Are there any suggestions for being able to hunt on ICS endpoints, for example, Windows Engineering Workstation, since EDRs aren't available in ICS environments yet?
There is some suggestions. I mean, one, what you should do is, especially in important systems like engineering workstations, also HMIs and data historians, at least collect the Windows event logs, and if possible, also the logs created by the applications themselves. Have a central log aggregator like Elastic or Splunk and collect that data. If you set up logging correctly, that would also mean, for example, collecting any type of PowerShell events. That will buy you a lot. If you can then install not necessarily EDR, but some tiny software from Microsoft like Sysmon that can enrich Windows events, you're almost all the way there. Actually, central log aggregation with knowing what to look for and something like Sysmon is more than half what you get with commercial EDR tools to begin with. So I would look that route. There's a lot of info about how to do that in the SANS reading room. So I'd look there to get started with how to set this up.
Great. Well, and that does finish our questions. Kai, did you have any closing remarks before we close out the webcast?
I think I'm done. You heard enough from me.
Okay.
Again, if you guys want to come to this ICS Europe and have more questions about this, looking forward to meeting some of you there. But also, again, SANS reading room, a lot of the stuff that I talked about is treated there at length. And with that, I'm done. Have a great Monday.
Thank you so much, Kai, for your great presentation. To our audience, Thanks. We greatly appreciate your listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. And a quick note, you can find your CEUs for this or any of your completed webcasts by logging into your SANS portal account. Navigate to your account dashboard, then click My Webcasts. You can then download your CEU on the right-hand side of the web page. Until next time, take care, and we hope to have you back again for the next SANS webcast.